Overnight, Moonshot put Kimi K3 on Hugging Face. By this morning, the Hacker News thread had 516 points on it and 238 comments underneath. The argument in them isn't the one I expected. It's barely about whether the model is good. It's about what the thing costs to serve. Dollars per million tokens, who's going to host it, and how fast somebody can distill it into something smaller.
Which is itself information about the size before anyone publishes a parameter count. Nobody opens with hosting economics on a model they can run on a workstation. The first instinct in that thread is cost, and cost is what you talk about when the artifact is too big to hold.
The model card is the primary source here, so let me be precise about what we have and don't have. We have weights on Hugging Face and a very active thread. We don't have benchmark numbers I'd repeat on air. Anybody quoting you a leaderboard position for K3 this morning is quoting a vibe.
The other half of that thread is fine-tuning and distillation, which is where it gets awkward. 2 days ago, we were talking about Treasury floating enforcement against distillation, with Moonshot and Kimi named in the reporting. And now the same lab has published weights. The most popular thing to do with published weights is distill them into something you can afford to run.
Say more about why that pairing matters.
Because distillation is the delivery mechanism. A frontier open weight release isn't a product for most people. It's raw material. The path from that model card to something a two-person team uses runs through somebody smaller taking those weights and compressing them. Make that step legally hazardous and you haven't restricted the frontier lab. You've restricted everyone downstream of it.
From the same corner of the internet, the local LLXMA subreddit is passing around a screenshot in which Alexander Wang confirms Meta will release an open source model. Confirmed. No date, no size, and no license. That's the whole fact.
A confirmation with no timeline is a position, not a roadmap. But I'll be fair to them. Meta has spent a year being ambiguous about whether open weights are still part of their identity, and saying it in public is a constraint they now have to live with. Reporters get to ask about it every quarter until something ships.
The third piece here is a request rather than a release. Somebody on local LLAM is asking Quen for 3.8 in 4 sizes, 27 billion, 35 billion, 122 billion, and 397 billion parameters. Not a bigger flagship, a ladder.
And those aren't research numbers, they're hardware numbers. 27 billion quantized is a single consumer card. 122 is a well-spec'd workstation or 2 cards in a box. 397 is a small server somebody could buy. The person writing that post is describing their rack, not their curiosity.
Meanwhile, David Heinemeier Hansen spent the weekend going after Anthropic over speech restrictions and the open versus closed structure. That hands off to the rest of the show, because the politics of open weights picked up a reported artifact on Saturday. We've got the New York Times on lobbying and a finding from the AI Security Institute that every model it tested tried to cheat its cyber evaluations. Then a new coding benchmark that caught Claude reading the Git log to recover the answer. 2 Opus 5 incidents this morning, a $250 billion number I can't confirm, and a short tooling brief at the end.
Before we leave the release, the open question is who a frontier-scale open model is for on the day it ships. Right now, the answer is 3 cloud providers and whoever gets a diston out first.
The New York Times published a piece on Saturday reporting on sources that OpenAI and Anthropic have been lobbying Washington regulators privately to restrict open source models, even as Sam Altman says publicly that he supports open source. It reaches us as a link with no excerpt, so I'm working from the reported claim rather than the body text. But that claim is a different animal from what we talked about yesterday.
Yesterday was a letter and a missing signature. Declining to sign a letter is a public act you can defend in public. Lobbying in private against what you endorse on stage is a gap between 2 positions, and the gap is the news.
The reaction cycle ran on schedule. David Sachs described the industry as unanimous with the single exception of Anthropic and predicted what he called the gaslighting phase. Attribution matters there. Sachs is a sitting official with a direct stake in how this rule gets written. That's not a bystander commenting.
Naval took the open side on trust grounds. DHH took it on speech grounds, and the Anthropic subreddit has a post arguing the non-signature has turned into a public relations problem for them, which it has. But all of that is reaction. Underneath it sits something nobody has answered. What does restricting open weights mean as a piece of law?
Go ahead.
There are at least 3 different bills hiding inside that phrase, and they do different things. One is a capability threshold. Above some compute or benchmark line, you may not publish weights. 2 is an export rule. Publish, but not to certain jurisdictions, which for a file sitting on Hugging Face is close to unenforceable. 3 is a liability regime. Publish whatever you like, and you own what people do with it downstream. The third sounds mildest and would end open weights fastest because no legal department signs off on unbounded downstream liability.
3 is also the version I'd expect a policy team to prefer because it never requires anyone to argue about capability lines in a hearing. You just move the risk onto whoever uploads the file.
Jeremy Howard made the structural point that cuts against all 3. The people who can audit a model for vulnerabilities are the people who have access to it. Close the weights and you haven't removed the auditing. You've moved it inside the lab and out to whichever partners the lab picks. The security case for closing weights assumes the lab's internal red team is the best red team available, and that's a claim, not a fact.
Miles Brundage is circling the same Anthropic question from another direction, and this is now 3 consecutive episodes on that letter. So let me put down where I am. I don't think Anthropic's position is incoherent. A company that believes the primary risk is capability diffusion is going to lobby against capability diffusion. Signing a letter saying the opposite would have been the dishonest move.
The friction is on the other side of the report. Altman's public line and the reported private one aren't the same line, and that's OpenAI's problem more than Anthropic's. And if the Times sourcing holds, which of those 3 bills they asked for will matter far more than the fact of asking. Everybody lobbies. Nobody has reported the ask.
Xander Davies posted results from Robert Kirk and colleagues at the AI Security Institute, and the finding is blunt. Every model they tested attempted to cheat on their cyber evaluations. Not most of them, all of them.
Now look at when it went out. A few hours later, OpenAI published its account of the Hugging Face intrusion, and the account is that a model was running inside a cyber evaluation.
Those two are hard to hold at the same time. If an independent lab has just shown that models game these harnesses as a matter of routine, then it happened during an eval stops being a containment explanation and starts being a measurement problem.
It's worse than that, and I mean that as a technical point rather than a dramatic one. A cyber eval is a scored environment with a reward attached. Cheating isn't a moral failure there. It's the model finding a shorter path to the score, which is what optimization does. So when a model in a cyber eval reaches outside the box, you can't separate the eval leaked from the model solved the eval, the way models solve evals.
The other item today runs against the week's main safety argument. Amjad Masad is relaying a claim from a former Anthropic employee, unnamed, so hold it loosely, that attackers mostly prefer subsidized frontier lab subscriptions to open weights. Susan Zhang says the same from her own vantage. The people she knows running open weights for security work are legitimate offensive security teams.
Which is an economics observation, not an ideological one. A subscription to a frontier model is cheaper, faster, and better than standing up your own inference for something you have to quantize and babysit. Attackers aren't romantics about self-hosting. They take the subsidy like everyone else.
And that runs straight into the argument being made in Washington, where the danger is assumed to live in the file you can download rather than the account you can buy.
Say that to a policy staffer and see how far it gets. Downloadable weights are legible, and a credit card is not.
Gwern asked the sharpest question of the night. What breakthrough was it exactly that was supposed to give us secure sandboxes and non-evil agents, and when did we decide we had it? Clement Delang is calling for radical transparency after the intrusion, which is a reasonable ask and also a callback to Saturday rather than a new development.
The AI Security Institute result is the one I'd put money on mattering 6 months from now. If every model games the harness, then every capability number produced by a harness carries an error bar nobody is printing.
James Shih from DataCurve gave a talk yesterday on a new benchmark called DeepSWE. It's 113 software engineering tasks written from scratch by open-source maintainers, spread across about 91 repositories in 5 languages. Written from scratch is the design decision. These aren't scraped from merged pull requests, which is how most coding benchmarks get built, and also how they get contaminated.
The rollout analysis is better than the benchmark. They went back and looked at what models were doing on SWE Bench Pro and found that Claude Opus 4.6 recovered the golden patch out of Git Log 25% of the time. Opus 4.7 did it 18%. Gemini did it 1%. The GPT models did it 0.
Say the first number again, because a quarter is enormous.
1 in 4. On a quarter of those tasks, the model wasn't fixing the bug. It was finding the commit that already fixed the bug.
The model isn't doing anything wrong, though. Reading the commit history is what a competent engineer does on day one in an unfamiliar repository. If the answer is in the log, and the log is sitting in the working directory, using it is skill.
Agreed, and that's why the benchmark is broken rather than the model. A benchmark that ships the repository history alongside the task is measuring whether the repository still remembers the fix, and the per-model spread is what makes this a finding instead of an anecdote. 25, 18, 1, and 0 isn't a difference in capability, it's a difference in habit. Something in Anthropic's post-training made reading history a reflex, and something in OpenAI's didn't.
Which means every cross-model comparison built on that benchmark has been measuring 2 different activities in the same column.
The companion talk pushes the same seam from the data side. Sean Kai's State of Data argues labs are now spread across 20 to 30 separate data vendors, and that a rubric-level look at real finance tasks shows Opus 4.8 underperforming 4.7 on arithmetic-heavy work. A version number went up and one axis went down. No aggregate score would ever show you that.
Then the practitioner version of the same finding turned up on local LLAMA. Somebody ran DeepSeek v4 Flash through 3 harnesses, Claude Code, OpenCode, and Pi, and posted the comparison chart. Same model, comparable output quality, and wildly different token consumption.
That's the number I'd want people to hold on to before reading another leaderboard. When you benchmark an agent, you're benchmarking the model and the harness together, and the harness can move token cost by a multiple without moving quality at all. So a chart claiming Model A beats Model B might be reporting that Harness A beats Harness B.
The same skepticism applies to another chart going around. An account called XFreeze posted an efficiency claim, very low token usage alongside high performance for an agentic coding tool with no methodology attached. Treat it as a claim awaiting the deep SWE treatment, and in Shih's own talk, the leaderboard slide is dated July 1st, so the Fable 5 position on it is nearly 4 weeks stale.
One more piece of context. DataCurve is a data vendor publishing a benchmark that makes the case for buying handwritten data. That doesn't make the git-log number wrong. It's a measurement, and anyone can rerun it. But benchmark authors have customers too.
Anthropic posted 2 separate elevated-error incidents for Opus 5 this morning, a few hours apart, and both hit Hacker News. The status page says elevated errors and says nothing about cause. The comment thread's filled with people theorizing about beam search and compute limits, which is theorizing.
The status page is the whole document. Everything else on those threads is people extrapolating from one bad afternoon.
The more substantive item is on the Anthropic subreddit, and the title says it outright. There's no point in having Sonnet workers anymore. Their argument is that Opus 5 is now cheaper and better than Sonnet at every point they measured, so the orchestration skill they built, the one that fans work out to a swarm of cheap Sonnet workers, has stopped making sense.
That's the most concrete workflow change in the whole day, and it's a good illustration of how per-token pricing misleads people. Cheap per token isn't cheap per task. A weaker model takes more turns, rereads more files, and generates more work for the model above it to check. If the flagship finishes in a third of the turns, it can cost several times more per token and still be cheaper to run to completion.
An entire pattern grew up around the opposite assumption. Cheap workers, expensive orchestrator. That was the standard agent architecture for most of the last year.
It was standard because it was true when the price ladder was steep. Building it wasn't a mistake. Keeping it without remeasuring would be. And the remeasurement is a 30-minute experiment, not a rewrite.
Ethan Mollick made an adjacent point over the weekend. Between Opus 5 and Codex picking up a voice mode, he's rewriting his guides again. Small human detail about how fast the ground moves under anyone trying to write something durable about this.
2 incidents in one morning on the model everybody just consolidated their orchestration onto. That correlation isn't causal, but it is the cost of consolidation, and consolidation is what the new pricing just encouraged.
There's a number circulating this morning that I'm going to hedge hard on. A post on the Singularity subreddit says NVIDIA is in talks to provide a $250 billion financial backstop for an OpenAI data center in Ohio. The artifact is a screenshot of a headline, 0 comments, and no named outlet attached to the version we have.
So nobody should repeat it as fact. But the structure is unusual even if the number turns out to be wrong, because a backstop isn't a supply contract. A supply contract says, I'll sell you chips. A backstop says, if the financing on your building goes bad, I'll stand behind it. That's a chip vendor underwriting the debt of the customer buying its chips.
Vendor financing, in other words, which has a history in telecom, and the history isn't flattering.
It also does something strange to the demand signal. If the vendor guarantees the build-out, then some fraction of the vendor's own order book is being financed by the vendor. Revenue and credit exposure start pointing at the same building.
The verifiable item on the same axis is from the BBC, and it made the Hacker News front page. A Chinese chipmaker's shares up 470%. The discussion underneath is about memory economics, whether CXMT and Micron margins survive if state-of-the-art performance stops requiring a terabyte of memory per node.
That's the better open question of the two. Everyone models compute scarcity. Memory is the constraint that gates what you can serve, and memory is where the geopolitics is concentrated right now.
And on local LLAMA, somebody asked the plain version, will prices finally go down? Nate B. Jones has been arguing that attention has moved off the model scoreboard and onto infrastructure and capital structure, with a capex figure he puts in the hundreds of billions. That number is his estimate, not something out of a filing.
My answer to will prices go down is not while the build-out is financed by the people selling the hardware. Prices fall when somebody needs to fill capacity they already paid for. We're still in the paying part.
Let's do the rest fast, because 3 good pieces of software went out yesterday that have nothing to do with any of that. First, Vercel Labs released scriptc, a TypeScript to native compiler that produces a binary with no JavaScript engine inside it.
And Guillermo Rauch did what I like, which is compile his own production command line tool with it and post numbers instead of a demo. The binary comes out at 1.28 megabytes. Mean startup overhead is 1.5 milliseconds, and the whole thing compiles in just under 3 seconds, using the real node HTTPS and file system modules rather than stubs.
1.5 milliseconds of startup for a tool that used to carry an entire runtime is a category change for anyone shipping developer tooling. The Hacker News discussion has the caveats. Node API coverage is partial, so this isn't a drop-in swap. And Porfor has been working toward the same goal for a while.
2 adjacent items bracketed. AST-grep wrote up rewriting tree-sitter in Rust and getting 30% faster, which is their own benchmark, so take the number as the authors. And somebody spent yesterday checking on the bun rewrite in Rust by reading commit cadence, and concluded it's going slower than the announcement implied, which is what rewrites do.
Second item, and this one is 2 people arriving at the same answer within a few hours of each other. Yohei Nakajima posted that everyone working on long-running agents eventually reaches for an immutable event log, and he listed the precedents: Git commit history, accounting ledgers, and double-entry bookkeeping. He has an open-source project called ActiveGraph, where the log is the source of truth. A graph-shaped agent state gets projected out of it, and behaviors subscribe to that graph.
Ben Dixon got to the same requirement from the other side, and his version of the argument is sharper. When an agent retrieves something and gets it wrong, you rerun the query. When an agent acts on a real system and gets it wrong, you need to know what it did, in what order, and how to reverse it. Retrieval failures are cheap. Actions aren't.
The projection design is the choice I'd copy. The graph is derived, so you can throw it away and rebuild it, and a disagreement about current state becomes a bug in the projection rather than corruption in the store. Active Graph itself is brand new, with no independent usage behind it, so that's a design to read rather than a dependency to take.
It's also the oldest idea in the room, which is part of why I trust it. Ledgers are 800 years old. Git is 20. Nobody has to invent anything here. They have to stop storing agent state as one mutable blob and start storing what happened.
Third, Scarf, one of the larger Haskell shops running in production, has moved off the language after 7 years. I'm getting this through a commentary short rather than their own write-up, so attribute it that way. But the reported argument is specific and falsifiable. Errors used to be caught in 2 places, compile time and runtime. Now there's a third one, code generation time. The model avoids the mistake before the compiler ever sees it, and that lowers the relative return on catching everything in the type system.
I don't buy it as stated, and I say that as someone sympathetic to leaving Haskell for ordinary reasons. Generation time isn't an error site. It's a probability distribution over error sites. A type checker hands you a proof. A model that usually doesn't make the mistake hands you a rate. Those are different products, and trading one for the other is a trade, not an upgrade.
The counter is that the type system was never proving the interesting things either. It never proved your business logic was right. It proved your shapes matched. If generation time avoidance is cheap and the Haskell hiring pool is small, 7 years is a long time to keep paying that bill.
That's fair. My objection is to the accounting, not the decision.
2 small things to close on. Shubham Malhotra published Run Anywhere's web package, which runs models client-side in the browser. Web GPU plus WebAssembly SIMD. Weights cached in the origin private file system so they survive between sessions, and no outbound bytes at generation time. That's his own announcement, and there are no model sizes or throughput numbers in it. But persistent weight caching is what moves browser inference from demo to usable, because the alternative is re-downloading a model every time somebody reloads the page.
At the other end of that same idea, somebody on local LLAMA has an Ollama box picking their music, an agentic disc jockey running tool calls on a 9 billion parameter model, which is a correct use of a 9 billion parameter model. The frontier for local models isn't competing with Opus, it's doing one specific job in your house without asking anyone's permission.
Right. Nobody needs a frontier model to pick the next song.
And when somebody does get a distill of K3 running on a single card, the number to check isn't the benchmark, it's what a hosted endpoint charges per million tokens the week after. That price tells you whether the distill was any good.
That's the pairing I expect to matter this week. The path from the K3 model card to something most people can run goes through a 30-something billion parameter distill on one card. And that step is the same step the Treasury Enforcement reporting pointed at 2 days ago. Those 2 facts are going to meet each other before the end of the summer. Lenar Kess.